Hello, it's me, Prabhat Ali. So currently I'm recording this video just to as a part of a project assignment given by Sital sir. So this is the tax. So we have like 3 different tax, and there are like soft tax associated with each tax. So the first tax was we were given a data set, a COVID-19 data set of Nepal. It's a CSP data set, and what we need to do is we need to replicate what's given in the problem. So basically what we need to replicate is we need to read the data and then get the summary statistics of the data. So yeah, so basically for doing that, I use library called readr, which is used to read CSV files. And I also have loaded the library harvest, which will be used later for doing the scraping purposes. And then once I like loaded these libraries, I just initialize, I just load this data in a variable called COVID_data and then provide the path here. So here is a read.csv function or method, which would allow us to read the CSV file from the path whenever we supply the CSV file paths. Okay, so once we read it, we can look at the structure. So which means like what kind of data, what are the variables involved with it, what data type does each variable represent, and then we can look at the summary statistics that we want to look, right? So here is minimum value, this is the first quantile value, and there is a median, mean, third quantile value, and the maximum value, you can say it. And what we need to do is we need to like omit this 0 values. So what we did is we select all those rows which has total cases equals to 0, because this is a kind of data error, we could say, because the initial COVID cases or total cases starts with 1, and in between there are 0 values. So it means like there is some data typing errors. So we filter those rows which has total cases equals to 0 and then replace it with 1s. And then we check the summary again, and then we can see summary is minimum. We can see that the total cases has a minimum value of 1. So that was the tax, and we replicated it. So the next tax was to read another file, this time not a CSV file, but a sav.sav extension file. And from that, what we need to do is we need to like get the frequencies of Q01, Q03, Q06, and Q08 variables, which are in that data file. So for that, so since this is not a CSV file, so this is a SAV file, we have like multiple libraries which we can use to read such kind of files. So one other library we can use is like Haven, but here we are using foreign package, and another package is like CT. So it's basically grammar of tables. We basically use it for like decorating the tables. So you can see we read this file from this path, and we have that read.spss like method to do that. And then once we read it, we can check the column names or the feature names of this data or presented in the data. And then for Q1, so for question 1, right? So we do like so we need to like we need to replicate this kind of table, right? We need to create this kind of table. So for creating this kind of table, we need like frequency for like Q1, right? So Q01. So for calculating this kind of table, we did this, right? So you can see we can just calculate the labels, right, for SAQ data, and then $Q01, and then we also calculate the frequency, right? So for that we use a table method, which gives us like how many which value has been repeated how many times. This way we can get the frequency, and then we converted this frequency into percentage, right? And then we round it off, right? We round it off to 1 decimal places. And similarly valid percentage also, we did it like the same way. And for cumulative percentage, so cumulative percentage, let's say we have 3 rows. So first is 1%, and second is 3%, and then third one is 5%. Then the cumulative percentage for the first row is 1%. The second row 1 plus 3 4%, and then 4 plus 5 9%. So that's how cumulative percentage works. So for doing that, we have a consum function to do that, and then we just created a data frame, right? So using data.frame, and then we just printed out the top 5 rows, and here you can see. So we still need to like create total, right? Total right up here. So for doing that, we like calculate the total frequency, total percent, and total value variation percentage. And then we again created another data frame, which consists of 3 different values. And then we left cumulative percentage as empty. And then the percentage and total valid percentage are like they kind of give same answers. And then we bind them together, like we combine them together. And then we add a title, like statistics makes me cry. And this title for generating such kind of titles, we use like CT library for doing that. Okay. So yes, this is how we created such kind of tables. Okay, it's not exactly like the one we were given, but like I try to replicate as much as I can. So for similarly for doing Q3, we first calculate the labels, right? So labels means we have like labels means this, like strongly agree, neither, disagree, strongly agree, strongly disagree. So these are the labels, and this is how we have extracted these values and here. And then similarly, we also extract the frequency for like QO3 right now, right? So QO3 is the name of the variable. There are like multiple variables in .sav data set. And for like this is the frequency statistics for Q01. And similarly, we did it for Q03, Q05, Q06, and Q08. I don't think we need to like go much deeper into it because I've already covered what I did, and similar process were used here as well. So similarly, like we calculate the frequency, right? So for calculating the frequency, we have a method called table, right? Which can always get like which values has been repeated how many number of times. We can get that, and we convert them into percentage, and then like whether that percentage is valid or not, we also like do a round off to 1-digit places. And similarly, we do a cum sum to like get the cumulative percentage. And then we created we created another like data frame for that. And then we just look at this head, and then for like generating the totals, like I said. So we have like done additional processing here, right? Total frequency, total percentage, and total validation percentage. And then we create another data frame for doing that. And then we try to bind the original data frame with the total data frame, and then combine them together. And then for the decoration purpose, we use like graphic grammar of tables. And yeah, this is the second table. We also like I try to replicate as much as I can, but it's still like it's still not like exactly like the one that has given. Okay, so going back to next one. So for doing Q06, so I think this is also the same process, like first calculating the labels, like right, extracting the labels, and then extracting the frequency, and then converting them into percentage, and then right rounding off to 1 decimal places, and then also calculating the cumulative percentage, creating a new data frame. And then since the total is not included there, so for calculating the total, doing some extra level of processing, calculating total frequency, total percentage, and total validation percentage, and then like creating another data frame which has 1 row and then like 3 different columns, and like 2 of them are left empty. And yeah, for labels, we have given total, and then we try to like bind them together, the original data frame for Q6, and then the data frame containing only the row part, like total, right? Total number or total frequency. And then we bind them together, and then we try to decorate like by providing a heading, like title to it. You can see I have little experience with computers here, right? So, and similarly for Q08, we extract the label, and then we calculate the frequency, and then we convert this frequency into percentage, and then round it off into 1 decimal places. And then yes, similar thing here. And then we also try to calculate the cumulative percentage, and then created a new data frame called Q08, and then try to look at the top 5 rows. And then since total is not included here, we do some extra level processing for calculating totals, and then creating a new data frame for this total row. and then binding them together, and then finally adding a touch by decorating it with a title. Here you can see I've never been good at mathematics. Okay, so that's with the part 2, right? Task 1, part 2, and now let's move on to part 1, task 3. So in the part 1, task 3, we are given Excel file like mrdocs.xlsx file. So we need to read them, and we need to like extract the variables like inco1, inco2, inco3, inco4, inco5 up to inco7 variables. And then what we need to do is like they have been encoded is they are like binary features like either 0 or 1, right? And we need to like what do we need to do is we need to replicate this. We need to like create we need to somehow replicate this table, right? So for doing so, what we did is like we tried to calculate the number of ones here, right? The n number of like ones. So that is, so what in inco1 variable, so how many of them are actually ones, right? And inco2 variable, how many of them are actually ones, right? So these are these numbers, so we try to calculate them. So for doing that, so we need to read them first. So since it's an Excel file, so we have used another package called read Excel, which is used to like read the XLSX or Excel files. So right, and then we also used like tplaware package, which is used for doing data manipulation. I mean data.frames or tables. And then we also use a table library. Okay, so we read this file, Excel file, by using this function, and then we try to select only those features because our area of interest is on inco1 up to inco7. So their variable name starts with inco. So this is what we do. We try to select only those features which starts with inco. And once we select those features, what we did is we tried to calculate the full sums because we are trying to calculate how many number of ones are there since they are only encoded with zeros and ones. So full sums will give the like frequency of like how many times ones has occurred. So and similarly we try to do in frames. So that means we try to create 2 different columns. So one for like one for income and one for n, right? So this is the name of the column, and then we try to mutate this percent equals to round n by sum of n into 100,1. So what does this code does is like this code takes a data set called inco and performs several operations on it. It calculates the sum for each column in the data set, so to calculate the frequency, and it converts the result into a tuple with 2 columns called named income and n. These are the name of the column names for the tuple, where income contains the name of the original columns, right? And the n contains their respective sums, which we perform here. And it calculates the percentage of each sum relative to the total sum of all columns and adds this to a new column called percent, and then it rounds up to 1 decimal places. And then you can see like this is how the table look like after like using this kind of functions. And then what we do in the next section is we just try to calculate in these 7 features, right? So how many how many zeros and how many ones are there? We just try to count their frequencies. And then based on that, what we did is we calculate another like feature. We derive another feature called percentage of cases. So which means like how many times it has one out of like how many times, right? So let's say one has occurred 226 times in inco1, but total number of times it has, total number of like values here is like around like 732 or I think 932, I just forgot. And when we try to like do this value, so okay, so 226 divided by 746, we get like 0.233, and when we multiply it with 100, we get 23.3%. So that's how percent of cases were derived. And then we try to do some formatting, and then like since in our desired table, right, we want the percentage sign as well. So we do some extra level of processing here. So yes, we added like the percentage value over here. And then finally, what we did is we tried to decorate the table using tab spanner and tab header. So what does this tab spanner does? This tab spanner, like it tries to create a header by spanning up to how many columns we want it to like include, right? So we want to include M, percent, and percent of case. So this title is spanned for these only three of these columns. And we also have tab header, which will span for all of this, right? So this will be a heading for all of these table. So yeah, that's how that is how the result has been created. Okay, so yeah, we so we try to replicate as much as we can, but there is still like we can like improve upon. So okay, so yeah, moving forward, so let's go to the part 2 where we need to do some data web scraping and data wrangling part. So for doing the web scraping, we need to like import RVest. We have already done at the front, and since in our first like task in like part 2, we need to scrape this COVID-19 data from India, right? So for that, we have these two URLs, right? So the first one is COVID, like data.mean.json, and another one is time series data. So I just tried to like load it by using this JSON-like library, and then JSON from JSON. What we did is we passed these URLs here, right? Both of them, and then we can just check the name of columns or check the most top level hierarchical features. So here you can see in COVID TS JSON data, we have this like this set of values. So this actually denote the name of the states of India. So you can clearly see here GJ, which stands for Gujarat, and yes, Gujarat, and BR stands for Bihar, right? So what are the and then like based on this data, we try to do some analysis on it. So what are the names of the states or state codes for which COVID cases were reported? You can clearly see. So these are the states where like COVID cases seems to be reported. And for doing some extra level of other analysis, like we try to like create a table, like a structure where we can get, so for each state, so how many number of cases were confirmed, how many number of cases were tested, and there are actually 3 different variants of COVID-19 in the data. So one is Delta, Delta 7, and Delta 2114 or 1421. So there are 3 different variants, and we try to create a good table which contains like for each state, what's the status of like Delta virus being tested positive, and what's the status of like people dying from Delta virus, right, in particular state. So for doing that, we created a function called extract delta values, and we tried to like create an empty list, and then we tried to loop over this data, JSON data, and then yeah, we did some extra level of processing. We tried to like create an state list, and then every state IDs has been included here, so that every time it runs through the loop, it tries to add every state into this state list. And similarly, what we did is if so there are cases like where let's say confirmed cases were not there for some state, or deceased cases were not there for some states, right? So for that, what we did is whenever there is no value present for a particular state in either of like confirmed cases or recovered cases or vaccinated cases or deceased cases, we try to like include them as NA. Another possible way to include them properly is like adding like if such values are not present, we can also like fill it with zeros, because since like so why it's like good choice to like fill it with zeros, because if like some Delta variant hasn't like seen any like disease cases in particular state, so that generally means 0, right? Because it has not been reported yet. So it has not been reported yet means 0. But like but for simplicity here, I just fill it with not applicable NA. So yeah, so whenever it doesn't like get the match for like confirmed cases, deceased cases, or like any other cases out of these six things, right? So if it doesn't find the information for that, it just fills with NA, sorry. And if it finds the information, it extracts the information and add in this list, right? So this way, like it tries to like go over all the states and tries to extract the test, how many test cases were like happened, how many of them were confirmed, like to have a Delta COVID-19 variant, right? How many of them have recovered from it? How many of them were vaccinated, and how many of them have died of it, right? So this kind of information we could get from this. So like we can just look at it. And finally, what we did is we tried to create a data frame. So where we pass a state list, and confirmed list, tested list, disease list, recovered list, vaccinated list, and vaccinated 1 and vaccinated 2 list here. And then we finally create a data frame for Delta variant, since there are like 3 different variants: Delta, Delta 7, and Delta 1421. So for Delta variant, so this is the data. So AN, so this is the state name, and where Delta variant confirmed is not. So that means in this state, so there is there hasn't seen like any like cases of having Delta variant, right? But like many of people have been tested, right? So so yeah, a lot of people can have a test for COVID-19, but they cannot have. So it doesn't mean like all of them have a COVID-19. All of them are not COVID positive, right? So that's why it's 0 here, right? And Delta vaccinated, 3 people have been vaccinated with Delta virus, and then like 13. So there are 2 different vaccinations for this. So yeah, so you can see. And similarly, we create another data frame for Delta 7 variant as well, and similarly with Delta 2114 variants as well, you can see. And then we finally try to combine them together and then create a whole data frame from it. So you can clearly see how we get we combine them together, and then this is like how the columns look like, right? So this is state, Delta confirmed, Delta tested, Delta disease, Delta recovered, Delta vaccinated 1, Delta vaccinated 2, and similarly for Delta 7 and Delta 2114. Okay, so I also try to look into answering some questions like how many people in Punjab died due to Delta variant. So here in this case, we need to first figure out what is the state code for Punjab. So that is PB, and then like how many people have been died. So for like looking into like how many people have caused how many people were died because of COVID-19, we need to look into Delta deceased column. So that's how we have selected them, right? So we have selected the state equals to PB, that is Punjab, and then we are extracting the Delta disease. That means how many people have been died from this. So you can see 1. So that means 1 people have died due to Delta variant in Punjab. Okay, so another question is like how many individuals is a percentage tested positive for the Delta variant out of the total number of tests conducted in Gujarat, right? So let's say there are many tests that have been conducted, and out of how many tests, out of all those tests, how many of them have been actually tested positive, right? So for answering this question, we first need to filter out all those rows, which consist of like which all those rows, right? From the state Gujarat. So this is how we did it, like we filter. So this is actually the DPLYR package allows us to like filter it like this, filter COVID DF, right? This is the data frame we have, and then we try to filter it like state equals to Gujarat. This is the state code for Gujarat, and then Gujarat Delta confirmed. So what we did, select Gujarat row. So from this Gujarat row, and then Delta confirmed, $Delta confirmed, okay. And then was tested. So how many were confirmed and how many were tested, and then the percentage, like Gujarat, the delta percentage confirmed, like out of how many tests, how many of them were confirmed. We wanted to calculate the percentage of it. So Gujarat delta confirmed divided by Gujarat delta tested into 100%. So that means, let's say if 5 people out of 100 have been tested positive, right? Then we can say the like percentage confirmed is 5%. Okay. So here, but here in our case, it's way less. It's not only like 1%, right? Because like if it's higher percentage, then okay, it's like it's really hard. Like, okay, so okay, so that's it with it. So we can do like a lot of analysis over here, but like I've just done this level of analysis. Okay, due to timing constraints. Okay, so now let's move on to part 2, web scraping. So where we need to scrap from this website, the Kathmandu city, and what we did is we tried to import 2 different packages, our Selenium and our Netstat. So since that table was updated dynamically, so I tried to like use Harvest, but like I wasn't able to like get access to the table that I was trying to fetch. So that's why I use Selenium. So first of all, what I did is, so there are a lot of like installation steps which I haven't like covered here. We need to install it in terminal or something. So I'm trying to use a Firefox browser, and then I'm exposing this port, and then I'm doing verb is equals to false. I'm actually initializing our driver object, and then it's initializing its clients, and then it is navigating to this URL, and then it is reading this HTML, and it's extracting the page source, and then it's trying to like unlist them, and then finally this is the code which tries to like extract them. So it tries to go into this HTML element. So this is the like class forecast body table, and then inside here we have another like class called table, and then we try to extract from these nodes, and then we try to store into forecast table. And yeah, this is the table we have. So yeah, so I think this is like kind of simple. We have already done that. And the last one, the part 3 assignment, where we have to, what we need to do is we have to go to Google Scholar, and then we have to type in the data mining topic, and then based on like whatever PDF documents were rendered to us, we need to download those documents, like just 10 of them. And I've also downloaded those 10 of them, and I've like instructed, I have created a directory, and I've stored all these documents over there. And yeah, for this, for like working with this, we need to install PDF tools. I have also done that, and once I install it, I need to like import this library so that I can use it. Another popular library in the space of NLP and doing text mining is like TM, which stands for text mining. So this library also needs to be loaded. And yeah, I set up the work directory as requested, right? So, and I've set up it, and then what I did is like PDF files, and then listed files, and then pattern equals to PDF. So since I am in this working directory, and I have like kept all of my PDF files inside this directory. So listed files, what it does, it tries to list all the files that is within this directory, or that is within the current working directory, right? And what I'm doing is like, there can be cases like there could be other files which could be present over there. So it's extracting only it's actually filtering only the PDF files, or only the files with an extension .pdf. So that's how we are extracting the PDF files. And then once we extract them, we need to read the documents or textual data from that PDF, right? So for doing that, we have an apply function from PDF tools, and we pass in all these PDF files, and then it tries to like what it does, it uses this library called PDF tools, and it goes through all these files and then extracts the PDF text. Okay. And then once we get this PDF text list, we try to create a corpus. So a corpus is nothing but like huge textual data set, which we can use for training training natural language task, like doing NERs or or creating document Tom matrix, or creating TF-IDF vectors, count vectorized vectors, and so forth. So yeah, we created a corpus, and then we just try to inspect the first three document of corpus, or first three element of corpus. And this is these are the first three elements of a corpus. You can say it's large. Okay. And okay, so once we get access to this textual corpus, what we need to do is we need to do some text cleaning operations over here. So first of all, what we did is we tried to lowercase all those letters, because the same values, let's say APPLE apple word, can be written in capital letters, and APPLE apple can also be written in small letters, although they possess the same meaning, right? But if we do not standardize them to their lower cases, these two things, or these two word, even though they have same meaning, can have two different vectors, or two different features. They can become different features. So to standardize this process, we try to lowercase this, right? And then we also try to remove some of the URLs, right? So since we have extracted all these PDF documents from Google Scholar, so where researchers can upload their research papers related to data mining. So in the research papers, there are a lot of citations involved in it. So we try to remove such URLs from it. So okay. And we're doing the function calling from tm_map, which is a text mining library, which tries to write whatever functions we write, right? Whatever text cleaning functions we write, we try to map that function to our corpus, so that it could clean, well, it could do whatever operations that we have applied in that function. Okay, so what it does, it tries to remove those URLs. And another is we also try to remove some citations. So citations are you can have a research paper, and then there will be large square brackets, and there will be numbers like 13 or 12 or 8. So we also try to remove that. Okay, so since they don't we don't want to form a word cloud from them. Okay, so that's why we are removing them. And then yeah, we're just inspecting whether it has been removed or not. Okay, and next one is we are trying to remove our punctuations. So full stop, question mark, comma, and then exclamation marks. So this are punctuations we are also getting rid of. So yeah, that's why we are removing punctuations, because whenever we are creating word clouds, that's full stop, comma, that doesn't make much sense for us. So because we're creating a document Tom matrix, and having a separate document Tom matrix for full stop doesn't make much sense. And we're also removing numbers. Okay, okay, we are also removing numbers. Any numerical terms like 1, 2, 3 or something like that, they get removed. And we are also inspecting them. And next process is removing stop words. So stop words are nothing but the most common or most frequent words that appear in our day-to-day language, like I, they, he, she, this kind of pronouns we usually use often. So we need to get rid of them, so that we can get the subject specific we can focus on subject specific words than those common words. So but we are trying to have because our programming, big data, and mining A and N. So these sort of words we don't want it to get rid of. So that's why we are expect these words, you can like remove all those stop words. And then we have removed them, and then we have again inspected them. And later on, we also try to remove new line characters like /n. So we also get rid of those new line characters. And then what other extra process? Okay, and we use like a stemming. So because the word like running, runs, run, they are like they have the same meaning, right? But when we do not like standardize it, right, they can refer to different features, right, which we don't want it to happen like that. So that's why we try to like uh, stemming is like a text normalization technique we use in often used in NLP, right, to just reduce their words to their root or base form, call it stem like root. Okay, so we did that as well. And then finally we just do a summary of the purpose, right? And then okay, it's I think it's big. I think I shouldn't have done that. Okay, let me go. I think I need to go up. Let me just go up a few words. Okay, so okay, so then what I do is like I create a document top matrix from this purpose. Like, so what it does is like tries to create a vectors out of like the words that have been used in the purpose. And then I try to inspect this. You can see dogs, a priest, accord, a chilling, action, algorithms active. Okay, these are some of these like features that has been created from this document Tom matrix DTM. And then we try to inspect the most frequent words on DTM from like corpus. You can see all these words have all words frequency. All these words have a frequency greater than 10. And then moving forwards, what we did is we tried to create a word cloud right from them. Okay, so we also try to see like which words are associated with the word data, like find SOX, which tries to find the correlations between these words, which word have been frequently used with data. So you can see mine is the word which has come like very often with the word data. And then we also create a word cloud, and for that we need a library called word cloud. And then we are creating a matrix from our DTM. And then we have like tried to figure out the frequency of each of these terms, right, each of the words. And then based on the frequency of each of these words, like the words which has the highest frequency, they appear bigger, and the words which has lowest frequency, they appear smaller. So okay, so that's how the word clouds work. So and then okay, there's a lot of warning been thrown here. Okay, let me just go down. Bottom. You can see these word clouds, right? So since like we are taking all those PDF documents uh, from all those PDF documents which has data mining topic in it. So that's why we can see like data, mine, set, model, cluster, measure, can, pattern, these kind of words that has highest frequency. But the words like popular, equal, hidden, these have lower frequency. And this is how, that's why like this is how your word clouds look like. And we are also doing some topic modeling, right? So topic modeling usually means like finding out the topic from the words or from the sentences. Okay, so here we are using topic models library, and then we are just sitting at 1 to 3 so that we could get for like reproducibility of results. And we are applying linear discriminant analysis, LDA, for doing the topic modeling. And DTM, we are throwing our like document top matrix, and we are using k equals to 4. That means we're only generating 4 topics, and then we are just printing the top 3 topics here, right? And then you can see the first document has the first 3 topics is data, value, and cluster, mind, variable, data, use, to data, object. Okay, so these are some of the topics that we can choose from for like first document, second document, and so forth. Okay, I think that's it for this presentation. So um, I hope like you like it, and I'm really hoping towards your constructive feedback on it. Yeah, like I said, like the lots of things I try to replicate to create the table, create the provided table as much as I can, but still like I'm not able to like replicate it to a full extent. So yeah, I would uh, definitely appreciate all the feedbacks that will be received uh, after you viewing this report. So yeah, thank you, and I'm really happy to present you my work.